Okay, so if you would just remember that in 2G, 3G, the node is called SGSN, and in 4G, it's distributed into MME and uh, SGW, EGW. So the configurations of MME for 4G perspective is a little bit different, since the HLR is replaced by HSS from your radio side. Your E node Bs, your node Bs, your RNCs and BSCs are replaced by E node Bs. So the MME configuration is a little bit different in that uh, perspective. So we're going to divide it into two parts. First, we'll cover the SGSN part, which will be basically covering the 2G, 3G configurations. And then we'll look into how the MME related configurations is done. Okay. So let's start from this. These are some 3GPP references, which you can further later download from Google. These are readily available, and then you can look into the advanced Okay, so you can download this 3GPP documentation, and you can look into the advanced level configuration, or if you need further understanding on some commands, on some parameters. Okay, so for GB, and this is then available interface wise: GB interface, IU interface, GR interface, GN, GP, and GA. And this is how we are going to ready as well with respect to the interface configurations. Okay. The objective is to understand the configuration of the local office data. Local office data means the configuration that is done with respect of the SGSN, and then understand the basic concept of the interfaces. This I think we have covered. We will briefly just summarize it, and then understand the networking and protocol stack of GBIU. This also we have covered. We will briefly go over this. And finally, is the main thing is the configuration and commissioning of these interface related information that we will be deeply looking into in this training session. Okay. So the first one is your local data office configuration. Okay, here what we usually configure is the system description, the time zone, the HPLM, the MME ID system, time protocol version. These all configurations are those configurations that is usually done when you bring up a new node. When you are commissioning a new node, you need to configure these, and then these are no longer required to be modified until and unless there is a very major change in your network where you require your time zone to change, or your home PLMN to change, or MEOT. But otherwise, it's mostly the the configuration related to your interface is something that is usually you're adding the BSC, you're deleting them, you're adding them through UL links, you're adding a new HSS, removing it. Okay, but just from the perspective of SGSN, these are some of the main configurations which are done in your SGSN. Okay, and the main thing that you need to look that you need to understand is that this is all the configuration is all SS7 related. Okay, so the SS7 data local office, it and its components are this signaling point code. You have the subsystem number, you have the SCCP number, the SCCP GT, and your map function. So all these we are going to cover later in the slides. Okay, different SS7 types. There can be an active network. They can be configured as a standby network, international active network, and international standby. So what we usually have configured is two. It's active local network, and then we have the active international network as well. We don't have any standby nodes available. Usually the node SGSN is working in an active mode. Okay, so the first thing that you need to understand is what is an SPC, the signaling point code. A signaling point code uniquely identifies a node in the signaling network, and a signaling point in two networks has two SPCs. So one is your local SPC, and like your local SPC, and one is your peer SPC. which we, in other terms, we call the originating point code and the destination point code. Okay, if you are asking about meeting link, it's the old meeting link. Let me just message in the group as well. Fine. Okay, so this is the basic understanding what an SPC is, and we have an OPC and we have DPCs, the originating point code and the destination point code. The other thing that we need to know is the SGSN number. You would be seeing the SGSN number usually when you check a user whether the user is successfully attached or not in the HLR. So when you open up the HLR, you see that if a number is successfully attached, the HLR will have the SGSN number. I mean, if you open a profile of an MSIGN or an MZ and you browse down, you will see that there is going to be an SGSN number and there's going to be an SGSN GT. So SGSN number is basically it is basically comprised of the country code, the NDC, the network destination code, and the locally significant part. And this is pre-configured in your SGSN so that once you get attached to one HLR, the HLR knows that this subscriber is currently latched or it is currently attached to which SGSN. So each SGSN is going to have a different unique SGSN number. Okay. Well, for example, in Jazz, we would be having +92, that is the country code. Then 300 is going to be the network destination code, and then the local significant part is something that is pre-configured in the SGSN number. Okay, so the numerical method that it uses is E164. The other one is E212, and then we have E214 as well. Okay, so the SS7, the main configuration is related to your SS7. Okay, and SS7 signaling data of the local office, the basic data on the USN that needs to be configured, and SS7 is involved in all of these connectivity. Whether you're communicating with STP, communicating with signaling gateway, HLR, VLR, RNC, EIR, SCP, it is usually over SS7. Okay, and we can further see this like SGSN has IP communication with each of these nodes, but so your layer 1 is going to be your IP, but your layer 3 you can see is M3UA. It's M3UA, so it's SS7 over IP. So all of these nodes have the SS7. The communication is through SS7 and it is via IP. So the IP layer is your basic layer 1, and then all the communication, your DPC and OPCs, all this communication is done over your SS7 signaling. Right. So configuring the SS7 data of the local interface, the first thing is you set the attributes of the signaling network. By local office, it means on the SGSN. So first, we're going to look into the configuration that is done from the perspective of SGSN. And then we're going to look that, okay, once SGSN is configured, then how do we configure the peer nodes? Okay. So you need to specify the signaling attribute. Then you need to specify the local entity index. This local entity index is usually unique, and irrespective of which node you are communicating with, whether it's with VSC, whether it's RNC, HLR, or any other, your local entity index remains the same. Same goes for your originating point code, your SCCP, since the communication over your layer 4 is SCCP in most of these cases. So your SCCP communication is via your subsystem number, via GT, and via your originating point code, or what we initially described as the SPC, this signaling point code. So you need to add the SCCP signaling point code of the local office. You specify the subsystem number, and you specify the GT, the address translation GT of the local office. And then when you have communication with HLR or those nodes which are communicating, the application part is map. So you need to specify the map function as well, where you define what is the map version and what is the map process option. This is something that we'll look into when we are doing the configuration for HLR for the GR interface. Okay, so in set signaling attribute, basically you need to specify which signaling attribute you're going to use, and it is usually SS7. Okay, the rest of the fields are usually constant field. They are usually not required. The main thing required here is one, the SS70, and what we're using is ITU2 underscore SS7. Okay. The next part is configuring the local entity index. Okay, the local office must be configured with the local entity of the M3 UA. Okay, so its command is usually this: add M3 LE. The variable part is your local entity index. This is the index that specifies this local entity. Okay, and then your OPC. This is your originating point code. This is going to be your SGC's signaling point code. So this same point code is going to be used irrespective of what sort of whichever node you are communicating with. The third thing is your LET. LET is your local entity type. This is something that we're going to see, that there are three different types of local entity type, and this all depends on how the SGSN is communicating, whether it's a direct communication or whether it's an indirect communication. Okay, I'll explain this a little bit later. Okay, and then you specify that, okay, this local entity is being defined for which node, so we specify that this is your SGSN. Or if you have multiple SGSNs, you can mention it's Karachi SGSN or it's Lahore SGSN or any other city-wise SGSN, however you are specifying your nodes accordingly. Okay, right, so you have configured your local entity, and that is then identified by your local entity index. The next part is configuring your SCCP originating point code. The local office SGSN communicates with the HLR and RNC using SCCP. This is something which I showed you in your protocol stack. Your communication is on the SCCP layer. Therefore, the SCCP layer signaling point code and SCCP is recognized. It is identified by your signaling point code via your SSN subsystem number and via your GTs. So in this part, we're just looking into how to define an originating point code of an SGSN. The SCCP signaling point of local office must be configured. Signaling point, it's a local office MTP3 layer, okay, and M3 UA local entity. So this is an example how you define your OPC of an SGSN. The command is add SCCP OPC. This OPX is your operating point code index, OPX1. So this whole configuration is identified by your OPX. And here the other thing to look that is of importance is your OPC, the operating point code. Okay, this is unique for your SGSN. Your SPN is going to be core only. There can be three different types of SPN. It's IO only, core only, and there's a third one as well. I don't seem to recall which is the third one, but usually for communicating on the GR interface, we use SPN as core only. When we're communicating with RNCs, it is IU only. And then you specify the SGSN number as well. The SGSN number, this is basically the GT of your SGSN, which I told you that this is visible in your HLR profile as well once the number is attached with the HLR. So this is the SGSN number, and this is where we identify the SGSN number. And then we specify that what is the name of this operating node. So this is again the SGSN number. This is configurable. International SPC for roaming will define here. Yes. For roaming as well, the signaling point code is going to be the same. The configuration for roaming will be covered in this, but your OPC is going to be the same as SGSN. Okay. Because your SGSN will not be directly communicating. Usually, you send your request to your STP. Your STP has your IMSI GT translation by which it will send it to your international your the international MSC or your international gateway, and then your international gateway will then be communicating with the peer ELMN uh, STPs and the international gateways. So from SGSN perspective, you just need to communicate with the STP, and your STP will then handle the request according to what sort of GT there is and which sort of MZ is requesting this service. Okay, so let's I think we can keep the chat part over here as well, so we can so I can just check if anyone is asking for any. Okay, the next part is your subsystem uh, number. Okay, the subsystem number is used to address your upper layer subscriber of the SCCP, and the SSN is usually now your operating point code is unique. This operating point code will be used for each of the communication, whether it's HLR, RNC, EIR. But your subsystem number is going to change. You will have a different subsystem number when you're communicating when you communicating with SGSN. If you have an app communication with RNC, your subsystem number is going to change. If it is on BSS application part, if it's on CAP, so each of these will have a separate definition of your SCCP SSN. Okay, and SCMG is basically your SCCP management. So for each of the configuration, like if you are defining it for your SGSN, you need to define for SCMG as well. Similarly, if you're defining for your BSS AP, you will define for SCMG as well. So add SCCP SSN index. This index will identify this configuration. If you're going to call this, we'll be doing it via this SSN index number. The subsystem number here we're defining is for specifically for SGSN. We can define it for an app as well. It can have the option of BSS AP as well. And this is the destination point code. The destination point code and the originating point code is going to be the same in this case, because we are configuring it for SGSN. Once we configure it for HLR, then your destination point code will be of HLR and OPC will be of SGSN. But since this is the local office configuration, so here your DPC and OPC is going to be the same. And then you have the SSN name, which is your local SGSN. So your subsystem number, your network identifier, your DPC, and the OPC are those variables which can be changed with respect to what sort of configuration is required. So once we go into the HLR configuration and GB and IU, I'm going to explain it more that how your SCCP SSN is going to vary with each of these nodes. Okay, the next one is your SCCP GT. Okay, and here the specific thing that you need to check is this the address. This address is basically the GTP of your SGSN, and the destination point again is point code is going to be that of the SGSN, which was defined as the originating point code. Since this is the local office, the SGSN level configuration, so the DPC is going to be the OPC. The rest of the configurations is usually predefined, or it's the default. Usually it is not changed until and unless you have a specific requirement to be addressed. So it's add SCCP GT. You specify the GT index. The NI is going to be NAT. Your it is going to be based on your destination point code. Your numbering plan is going to be your ISDNP. Okay, this is a little bit different for SGSN. It is ISDNP, and for HLR it is ISDN. Okay, and your the address here is your GT of the SGSN. The destination point code is your signaling point code of your SGSN, and the name can vary accordingly. Okay, so that app function, I mean, if it is not specified as it states, there is a default value of which version of map is going to be recognized by the SGSN. However, if you have a specific requirement, you can specify that which map version is being supported by your SGSN. So here we are using V2 plus. Okay, so now we have understood how to configure them in CFCC, what's the function of SCCP GT and set signaling attribute, how is it set and what is its impact. Okay, so now we are going to be configuring the peer node configuration, and we are going to start with your GR interface. As all of you know that GR is the interface between a SGSN and the HLR, and it is used for both 2G and 3G communication. And the protocol stack or your communication or your interface for GR is similar with respect to when you're considering the SS7 communication. It is similar for GD, GSG, GF, and LG interface as well. So once you understand how GR is configured, you can easily configure the rest of these interfaces as well. A little bit of recalling that how this communication, so it's that the protocol stack is IP, and IP you have SCTP, then M3UA, then SCCP, then transmission control application part, and final application part is your mobile application part, your map messages. And this is something we looked into when we discussed the traces as well, the how to identify the communication between SGSN and HLR. Okay. Map protocol, there are 3 versions of map protocol: phase 1, phase 2, and phase 2 plus. The variation in all of these phases is based on what functions are to be utilized. Like phase 1 had the basic function, that's some additional functionality, and phase 2 and then phase 2 plus had some more additional functionality. Okay, so it all depends on your network, which phase you are supporting, which phase your peer node is supporting, and then accordingly you can configure the map protocol. Okay, the SCCP configuration table, this is something we checked previously as well when we were configuring the local office. So first you specify the OPC, a list of SCCP originating signaling point code. It identifies the protocol address of the local SCCP entity, which in this case is SGSN. Then you specify the destination point code, which is your peer node. It includes the data related to any signaling point that exchanges SCCP message with originated signaling. So originating is SGSN, and DPC is going to be different for RNC. It is going to be different when you are communicating with HLR and so on and so forth. Then you have the SSN, the local address information used by SCCP. It identifies each SCCP user on a node. Like I explained, that every destination point, every destination entity is going to have a different subsystem number. And each of these destination node will have a GT as well, because you will see that why an SCCP GT is required, your global translation is required. You need to have a translation defined in the SGSN to identify that which node you are going to communicate with. What is the map, and for what we need that? Khalid, map is an application layer protocol, and map is basically used for communication on the GR interface. When you're communicating with HLR, when you're communicating with EIR, when you're communicating with MSC over all of these interfaces, like I mentioned here, GD, GS, GE, GF, and GR, your mobile application part is the application layer protocol on which the communication is done between SGSN and the rest of the entities like MSC, HLR, EIR, and other nodes. Okay, so it's a layer 7 protocol that is used for communication between SGSN and the peer nodes. Okay, so this part is your SCCP configuration table. If we go back, so this is the SCCP part. So this is the configuration on this layer. The communication on SCCP layer will be based on the configuration we do here. And then come the M3UA part, the communication on your layer 3, which is your SS7 over IP. Its configuration is done via these commands. The first one is configuring your local entity. Then you configure, since you have a local entity, then you need to configure your destination entity as well. So local entity is SGSN. This is we already configured it, and as I explained to you, that local entity, the ID and all that is going to be the same, irrespective of which destination node it is. Obviously, with every changing destination, the M3DE is going to be changed. So your destination entity is going to change. Then each destination entity will have its link set, a list of M3UL link set. So M3UL links are combined together in a link set. So if you need to perform any routing, if you need to do any configuration change, so every link is bound together into a link set. Okay, and then every link and link set need to have a specific route. Based on this routing, your communication on this M3 link is going to is going to reach to your destination entity. So your local entity, destination entity, your link set, your M3UL link, and then your M3UL route. Right. So since we are looking into cloud configuration, so I mean, if you look into your protocol stack, your routine protocol stack, so your L1, L2, and IP, then you have SCTP, followed by M3UA, SCCP, then your the transport part, and your mobile application part, BSS AP. So all this is SS7 or IP. From cloud perspective, since we have different VMs, so this communication, your L1, L2, and IP communication is being done by a IPU VM, and the rest of this communication is basically being handled by a SPUS, your SPU VM. Okay, so the configuration for IPU is going to be a little bit different as compared to SPU. So this differentiation uh, is being explained here, that which part is going to be covered by IPU and which part is going to be covered by your SPU. Fine. So we have had an overview of the interface, and now we're going to see that how the interface addressing is done. Okay. According to the different address modes, there are two different address modes that needs to be used. Okay. One is your DPC or destination point code accompanied by your SSN, and the other one is your destination point code along with your global title. Now, when we are doing the configuration of HLR, we need to have two different global titles. The first one is we need to specify the HLR number. The numbering plan here is ISDN, and it is used to address the HLR when HLR message is replied. So wherever there is an incoming communication from HLR towards SGSN, so this HLR numbering plan is used to identify that this HLR is communicating with us and we reply back. The other one is your IMSI number. The numbering plan is your MSISDN. It is used for HLR initial addressing after routing area is updated. Since you get an attached request, you get a routing area update request, your number does not specify that, okay, which HLR do I need to communicate with? So how does your SGSN identify that this number is located in which HLR? That is based on your IMSI number. You have your IMSI GT translation, and based on your IMSI GT translation, you're going to look into it, that how your IMSI from your IMSI, how the SGSN identify that which HLR is hosting this IMSI, so that request to that specific HLR can be sent for location update, for your authentication and authorization. Okay, so for incoming communication, your HLR number is for outgoing communication, your IMSI number and your GT translation need to be done. So there are two different GT numbers for HLR. Now, where do we use DPC and where do we use DPC for GT? It's explained here. If there is no signaling transfer point, there is no STP, and you have direct communication with your HLR. In that case, you use your DPC plus SSN. And in case you have STP available, signaling transfer point, which is an intermediary node between SGSN and HLR, in that case, you use your DPC plus GT addressing mode is recommended. And then your each HLR is identified by one ISDN, and it's a unique ID of the HLR in the global area. So it's a GT basically. The MSISDN code has a similar structure with ISDN, and this we already know that we have the CC, and then we have the NDC, and then we have the actual mobile code of a number. Like it's 92 is your country code, the NDC is your 300, and then you have your number accordingly. So similarly, your HLR GT is going to start like this, going to be the CC, and then it's going to be the NDC, and then there's going to be the actual the local HLR number. Okay, the comparison between your DPC and DPC plus SSN. Okay, when your DPC plus SSN is used, your SSN number is actually what is configured in your SCCP command. So in SCCP command, you specify this is a number, and that is going to be the subsystem number that is used for communication. When it's only DPC addressing mode, then your subsystem number is not, because since you're using just DPC, you're not configuring the SCCP. So in that case, your SSN is going to be sent from the user layers. Your user layer is going to share the subsystem number to your SCCP layer, and based on that, that SSN is used for further communication. So in SCCP port sharing, you all know we can configure the STPs to work in load sharing, and we can configure them to be in active standby as well. So this is your originating signaling point and destination signaling point, and these are then and then they are linked with two different STPs. Each STP has a link set, and each link set will then have multiple links, like we mentioned in the configuration part and through a configuration part, that this is, let us just go back here. So link set, link, and then route, and then this is your local entity, and this is your destination entity. So we're coming back here, local entity, destination entity. This is your link set one, this is your link set. Each link set is going to have a different link, and then there is going to be a specific routing that how this node is going to reach this node, then there and through your route as well. Right. So first we're going to look into the configuration. If your SGSN is directly connected to your local HLR, there is no intermediary node like STP involved. Right. So these are the different three modes. The first mode, obviously, like we checked that the SPU is your signaling processing unit, and IPU is your IP communications. So your direct connectivity on a link level connectivity is going to be via IPU. So this is your direct connectivity with HLR, and if you're using STPs, then you're communicating with most of the STPs, which are then going to be connected with your HLR. And your third mode of communication is when you are connecting with other PLMN, like it was already asked that if you are doing the roaming configuration, and the same configuration on SGSN end, and then you send your request to the STP, and then STP is responsible for then communicating with your other PLMN, STP, and gateways as well. So first part is this one, when you're directly connected to your HLR. This is an example of a data planning when you are commissioning a new HLR. A new HLR is coming. That this is the sort of information. It may vary, but the standard information is like this, that you will have your planning team is going to provide you, or if you are the planning team, that there's something the table that you need to fill. You need to specify the service IP. Service IP is the local SGSN IP. So we have two IPs of the SGSN, and then you are going to specify the port. For each IP, there's going to be a specific port, and then you will also be provided with the HLR IP. So there are two IPs of the HLR: first IP and its port, the second IP and its port. Then you will be provided the operating point code, the OPC. This is for SGSN. This is the GT of the SGSN. The DPC is going to be the destination point for the HLR. This is the peer entity and then this is the GT of your HLR. Then you will be obviously be knowing what is your mobile country code and mobile network code. These are the first 5 letters of your MZ, and your country code and your NDC. These are the 5 letters or the 6 letters that are used in your MSISDN. So you need to translate your MNC and MCC into CC and NDC. Okay, and here it specifies the matched MZ. The matched MZ mean that okay, this is the total part of the MZ that needs to be translated into your CC and NDC as well. This part I'm going to explain a little bit later. And then you also need to specify that which addressing mode is being used, whether it's DPC plus SSN or DPC plus GT. Since this is direct communication and we already looked into it, so it's DPC plus SSN. The commands, the first one, signaling attribute, this is already configured because it is configuring for localization, so this is only configured once. Set service IP. In service IP, we configure the local IP addresses. The local IP addresses for GR communication is going to be different. For RNC communication is going to be different. For DSC communication is going to be different. For MSC is going to be different. So in add service IP, you specify the what is the local IP address of your SGSN. Then you specify your local entity. Again, this will not change. This will remain the same. The destination entity obviously is going to change. The link set is going to change. The routing is going to change. The link is going to change based on the IP addresses of your peer entity. Then you configure the SCCP part. In SCCP part, you configure the operating point code, the originating point code. This is of the SGSN already configured. The destination point code of the HLR, the subsystem number of SGSN, and then the subsystem number of the HLR as well. So SGSN 1 is already configured when we were doing the local data, local office configuration. This HLR 1 is something that will be done based on the information that is provided by the peer team for HLR. Then is your GT translation. The IMSI GT translation is basically how your IMSI gets translated into your NDC and NC, your NDC and PC. And its significance, once we come to step 12, I will explain to you that why this IMSI GT translation is required. And then you configure the SCCP GT for your local SGSN and the SCCP GT for HLR. This is the case when for global title configuration to identify the PT. So set signaling attribute. This command we already looked into. This is just done once for the whole SGSN. So you do so once, even if you're configuring again and again, this command is not configured again. This is just configured once, and the main thing is that it ITU to SS7 configuration is done. So you specify. Believe GT is your global title. Okay, like you have. Let me just explain it like this. Okay. Let's say that is this one. Okay. Let's use this one. Okay. So your MSISDN is okay. Let's say your MSISDN is something like this. 92, or I will quote my own. Okay. This is my number. Okay. So this part is your country code is +92. Your NDC is it's usually the first one. Okay. So in my case, okay, I'll say this is, and the rest of my ISDN is this one. Okay. So I mean, if I am communicating, if I'm in roaming, I am roaming and communicating externally. My number, all my communication is based on IMSI. Okay, it's based on IMSI, and my IMSI, for example, is 41001 and then 8288 and something like that. Okay. So once I send a request, because if you look into all the tracing and all that, the communication, all the thing is based on your IMSI. Everything is based on your IMSI. But this 41001 does not recognize, like my operator is, I'll say the operator that is serving me the service is Jazz. Now Jazz is recognized by 92300. Okay, this is something that is unique. This cannot change. Globally, Jazz is registered via +92300. So each of the any of Jazz must start with 92300, or it can be 308 or anything like that. So this is something that is uniquely recognized by Jazz. But my communication, the IMSI level communication, is being done via 41001. And maybe there is some operator out there like operator XYZ whose country code is going to be 41 and whose NDC is going to be 001. So if I continue my communication based on IMSI, it is going to be okay. So if I communicate based on my IMSI, the international signaling gateway are going to recognize that okay, I belong to this operator XYZ. I do not belong to Jazz. In order for me to be recognized to be a number of Jazz, my IMSI, my MNC and MCC needs to be translated to my my CC and NDC. Okay, so each of the nodes of Jazz, irrespective of whether it's an MSC, whether it's HLR, whether it's any other node that is used for international communication, that must start with +9 to 300. Okay, and this is the global title. This is the identity that is being okay. This is the unique identity that is being recognized internationally by each of the nodes internationally, your international gateways, your international MSCs and all that. They recognize the global title to be a unique identity. Okay, so HLR is will have its unique identity. MSC is going to have its own unique identity. Even your SGSN is going to have a unique identity, and that unique identity is your GT, your global title. Okay, so your GT uniquely identifies your node in the international layer. Then you have international communication. So there is should be one specific ID, like you have your NIC, your network, your identification, your national identification number. Okay, so that is unique. So no other person can have that identification code. So similarly in GSM communication, all of your nodes are going to have a unique identification code, and that identification code is going to have a unique GT. Yes, MSC, HLR, GSN, each of these will have a unique GT. Okay, your HLR and SGSN GT cannot be the same. So once you are doing network planning, you need to identify that okay, this is going to be the unique GT, and you need to check in your network that this GT is not being used for any other node. Okay, so you identify that, you assign that unique GT to that node, and then you populate that in your IR21 and your IR. I believe for packet core it's IR21. So you specify the unique GTs and propagate it to all of your international roaming partners as well. That okay, this is the unique global title, the unique identification of our SGSN. And same goes when you're roaming. You add an HLR, you update the HLR GT as well, MSC as well, and so on and so forth. Yes, obviously, I mean, if you are configuring a node, you need to configure its GT as well. You need to assign that node a GT as well. Otherwise, it is not going to recognize, or the other nodes are not going to recognize that which GT, which node does this GT belong to. So once you are configuring a new node, you need to assign it in its local commissioning that what is its global title as well. Okay, so that is being done in your SCCP layer. Right. Okay. So in your GT translation table, it's your MG GT, your SCCP GT for SGSN, and your HLR. Right. The first one is just signaling attribute. We already covered. It's SS7. The next one is configuring the service IP. So the command here is add service IP, the OMO VNFC. If you are using cloud, you need to select the operation and maintenance VNFC, and in operation maintenance VNFC, you will specify this IP address, which is going to be the IP address for your SGSN. So SGSN is going to use this IP address to communicate with HLR. So I mean, in this, we identified that these are the two IP addresses. So these are the two IP addresses which we are configuring in service IP. Right. So this is the M3 UA entity type. Like I mentioned to you that the local entity type, there can be three different entity types. One, your ASP, application server process, the SGP signaling gateway process, and your IPSP, the IP server process. When you have direct communication between SGSN and HLR via M3 UA link, in that case, the entity type locally and for the destination is going to be IPSP. However, if you have an intermediary node like SG, consider this as the STP. In that case, the M3UA communication will be where STP and STP will then have an MT3P link with HLR or any other protocol that is being used. In that case, your local entity SGSN will be configured as an ASP, application server process, and your destination node is going to be configured as an SGP, the signaling gateway process. So, I mean, for example, the SGSN directly communicates with RNC. So once we're going to look into IU, the configuration of local entity is going to be IPSP. But since here we are configuring, we're checking both HLR direct and indirect. So in direct communication it will be IPSP, and in indirect is going to be ASP and SGP. And since we are in this part of the training, we're looking into direct communication. So here we are going to configure it as an IPSP. So here, how to configure the local entity? The local entity at M3LE, the local entity index is going to be unique. The operating point code is SGSN, and here you can see the entity type is IPSP. Now, destination entity is the HLR. So its destination entity index is going to be 1. The local entity index is going to be 1. This one comes from here. So this is how you the DE is mapped with your local entities. So this destination is going to communicate with this local entity. Then this is the destination point code. This is of the HLR. Then SLSSM is basically to identify that how many links with this HLR do we have or STB do we have. If there is only one route, it is going to be 001. So it's working in binary form. If it's 2, it's going to be 0001. If it's going, 0010. If there are 3 links, it's going to 4 links is going to be 0100. So it all depends on it is specifying that how many links with this destination entity do we have. And then the main thing is your destination entity type. Since it's direct communication, it's IPSP. And then you specify that what is the name of your destination entity. So that is your HLR. Here's the description. What does DPC stand for? What does SLSSM stand for? Destination entity type. And since it's a direct connection, so your adjacent function is true. And then this is the M3 protocol version. This protocol version needs to be same. This is the protocol version that is supported by HLR, so you will configure the same protocol as well. The next is your M3VA link set. So first you configure the link set, and then you will configure the links into it. Okay. This command is used to add M3VA link set. Only one link set can be configured between 2 adjacent M3VA entities. Okay. So with one HLR, you're just going to have one link set. You can have multiple link sets. Okay. One link set, and then one link set, you can have multiple links. So you add M3 LKS, you specified the link set index. This is 1. The destination entity index is 1. The DX come from here. Okay. And LSS is something that uniquely identifies this link set. Then SLSM is B001. So B01 means that there are 2 links. In this link set, we are going to define 2 links. So we are setting it to 001. Then work mode is IPSP. This is already, we know that destination entity type is SP, the local entity type is IPSP. So the working mode is going to be IPSP. How is it going to work? It is going to work in load share. These 2 links are going to work in load share. It can be active standby, it can be load share. So we are here specifying that its mode is going to be load share. And then you specify the name of the local set name that is towards the HLR for you to better understand that, okay, this link set specifies for communication with which destination node. Next is your M3 route. So you specify the route destined for your HLR, and here you have add M3RT is its command. The route index uniquely identifies this whole route. Then destination entity index is 1, and then LSX is going to LSX is this one. So it is specifying that this route index is what? This is route index is between this destination entity index, this destination entity index, which is specified by this destination entity, and the the link set index is this. Okay, so I mean it is connecting like M3RT route is basically connecting this link set to this M3DE, and then M3DE is connecting this destination index with your focal entity. Which thing is by default? LS, yes. LS, no, it is not by default. You have the option of configuring. Usually there is no sense in configuring the links in active standby. Usually you configure the links in code share. So it all depends on what your operator is suitable with, depending on how many links you are configuring, what is the capacity between your links, and how many links. So based on that, you can specify it via code share. But I don't think I've seen anywhere it working as an active standby. The links are usually in load share. Right. The next part is your M3O. So you configured your link set, you configured the routing, and now you're configuring the links. The links are going to be configured in your link set. Okay. So its command is add M3 link. What IP is being used? The IPv4 is being used. The local IP, the first IP is this. It's accordingly the port is this. The peer IP address to the HLR is this, and its port is this. This information you will get from the table which we discussed earlier. The CS is basically indicates whether it's a client, it will be working as a client, or whether it will be working as a server. Okay, and then this link will be part of which link set index? It will be part of link set index 1, and then SCTP index 0 is being used. You specify a different SCTP index for every communication. For GR, it's going to be SCTP index 1. Maybe for IU communication, it's the index 2, index 3, and 4 accordingly. Okay. So here's a bit of description. The local IP, you can understand what local IP is, the local port, peer IP, peer port, and the CS means the client and the server side. What needs to be configured is based on what sort of link you are being using. If it's an ASP, it's going to be client. If your working mode of the link set is SGP, it's server. And if the link set working mode is IPSP, then it can either be client or server. Okay. In this case, what the working mode was IPSP. So we are going to configure here the CS is going to be server. It can either be client, it can either be server. Okay, but the M3UA link is usually the client initiates, so it's a server. Client initiates a request. Okay, activate, deactivate the link. No, a link can be activated, deactivated from both sides, but in client server communication, it's usually the client that is requesting the service, and server is the one that responds to that request. But its activation, deactivation can be done from both sides. You can reconfigure the link, you can lock the link. It all depends on which side is more comfortable in blocking the links or activating, deactivating the link. Okay, add an SCCP OPC. Now we're coming to the SCCP communication. Okay, the operating point code, this we already configured previously, just mentioning here. The operating index is 1. The operating point code, this is the point code of your SGSN. Your SPN is the signaling point purpose. Like I mentioned, it can be IU only, it can be core only, it can be IU and core. For HLR, we use core only. For RNC, we use IU only, and IU and core is used if the same SCCP OPC is being used for both. HLR and RSC communication, and then you specify your SGSN number here as well. Then comes your destination point code. The destination point code is going to be the point code of your HLR. So your SCCP DPC, the DPX3 is your destination point index, and originating point index is this. So this command is basically linking this destination point code to this operating point code. Okay, so show that okay, the communication between this DPC and this OPC, and your destination point name is your HLR1. Like, next is how to configure the subsystem number. Okay, the subsystem number for SGSN, like I told you that since it's SCCP communication, so this SCMG is going to be configured every time. If you're configuring SGSN, this needs to be configured. If you're configuring HLR, again, this needs to be configured. So when you're configuring from the SGSN side, the OPC and DPC is going to be the same, that of the SGSN. But when you are configuring the link with the HLR, the OPC is going to be the SGSN SPCs and the DPC is going to be your HLR SPC. Okay, so here is an example of configuring the SGSN, the local office SCCP subsystem number. So the command is add SCCP SSN. Then this is the subsystem number index, which identifies this whole command and the communication in this. And here it's the SCCP management. The subsystem number is SCCP management, which is a default command which needs to be added. And here it is linking your destination point code with your originating point code. And since it is being configured for SGSN, your DPC and OPC is going to be the same. And when your subsystem number is SGSN, then again the DPC and OPC is same. Next, we are configuring the subsystem number for HLR. For HLR, again, the SCMG needs to be configured by default, but here the OPC is your SGSN signaling point code, and DPC is going to be your HLR signaling point code. So this same OPC is going to remain the same. The destination point code is going to vary with your specific node. And the subsystem name is HLR1, so you can specify whatever HLR name is required. It's HLR1, HLR2, HLRA, HLRB, whatever is the naming convention in your network. This is something that you can specify. And here it's specifying that the DPC is that of the HLR and your OPC is that of the SGSN. Okay, now comes your IMSI GT translation. I think I have explained this. Let's review this part as well. Okay. I think if we come over here in this description, you will better understand. So when a mobile subscriber initiates an attached request, there is no HLR number of subscriber in the SGSN. Okay, so SGSN does not know which HLR has the profile of this IMSI. Okay, the only information for addressing is the IMSI available, which you saw that your attached request, any other request, even if you are not sending the IMSI, you will get an identification request, and your SGSN is going to get your IMSI, because IMSI is your for communication. In your international, in your ITU to SS7, IMSI cannot be used directly for HLR addressing. Okay, which I explained to you. The IMSI needs to be converted to GT, and then GT is used for HLR addressing. So this process is called IMSI GT conversion. Like you convert your MNC and MCC into your CC and NC or NDC. The IMSI GT conversion is to convert the MCMC to NCC NC of GT. The MSIN can be obtained by mapping. The MSIN remains the same. Okay. So the CC and NC identifies your PLMN or an HLR in the PLMN of a country. Okay. It is not recognized by your MNC MCC. It's your CC and NDC or NC, like I explained to you, it's 92300 in case of Jazz. This is what is globally recognized that, okay, this is the HLR or this is the CC NC of Jazz, and then plus 92300, and then the identification, the MSIN is going to be that of your HLR. Okay, so NC can either be the destination core NDC followed by several numbers. Yes, so this is the command. The add IMSI GT is used to configure your IMSI GT conversion in SGSN. Okay, so you specify the MNC and MCC, and you specify the CC NDC. So your so from your MZ, your MCC and MNC is replaced by your CC and NDC, and then this is something that is globally recognized by your international gateways, by your international MSCs, your gateway MSCs, your STP recognize that okay, this CC and NDC belong to some specific PLMN. The MZGT conversion must be added in ITOS7 network for addressing the HLR. Okay. In case, even if you're not using roaming, in case it is a local attach request, again, your HLR is going to be identified based on your CC and MC. Your MZ is your MCC and MNC of your MZ is going to be converted to your CC and NC, and then based on your MSIN, your specific HLR is going to be identified. Okay. So now we are configuring the SCCP GT for the local SGSN. For SGSN, you need to configure the GT according to the SGSN number. Otherwise, the transmission will fail. Okay. So the local SGSN number needs to be specified, and that is being specified using this command, the SCCP GT. Okay. And your numbering plan is ISDN numbering plan. This is your GT of the SGSN number, and this is the destination point code, which is the operating point signaling point code of your SGSN. Next is your SCCP GT configuration for your HLR. So for HLR, it is going to be okay. Here the numbering plan was ISDN, ISDNP. For HLR, it is ISD NMS. Right. So this is the address of your HLR, and this is your destination point code. Okay, and configuring the SCCP G translation of the HLR number for your IMSI conversion. This SCCP GT is going to be used, and for your identification of your HLR when the incoming communication is from your HLR, in that case your GT index 2 is going to be used, which will specify that okay, this is the number of the HLR, which is incoming communication, and its destination point code. The subsystem number is HLR, and its name can be configurable to the HLR name. The MZGT command will, I think it is covered in roaming. So once we come to the roaming part, I will explain it a little bit more that how it works. Okay. Okay. Next, we're going to see the configuration of your USN via STP. If you're communicating with your HLR via STP, so how the communication is going to change. This is the networking model. Okay, you communicate with your STP, and from STP you communicate to your HLR. Okay, this one. So the IPUs communicate with STP, and then you go to your HLR. Again, we discussed this. Now the SGSN will be configured as ASP, and your STP is going to be configured as SDP. Previously it was IPSP and IPSP. And this is the data planning communication, the data planning table that will be received by you from the planning team. The local IP addresses, the OPCs, the local entity type will be specified as this, the routing code, your network appearance. So all this, and your peer IP address. So based on this, you're going to perform the rest of your configuration. Okay, your SCCP's signaling information and your GT translation information. So add SCTP para. This SCTP para needs to be configured for each of your peer node. If you are communicating with HLR, you need to configure its SCTP para is going to be 1. For RNC is going to be 2. For if you're coming with MSC is going to be 3. So it's going to be unique for each of your destination entity. This is the same service where you specify your local IP addresses. This is the local entity. Here you're going to see that the local entity type is ASP, and your destination entity type is SGP. The rest of the information is the same, which we already covered. Okay. Next is that you are configuring your link sets. Again, you're going to say that the working mode here is ASP. Load share, and the rest of the information is the same, like your destination index and your local link set index. And via configuring your M3 your route. You are specifying, I mean, you are specifying a route for your multiple link set indexes, like link set index 1, link set index 2. So you're going to specify a priority as well. You have the option of specifying the priority. For example, you have STP1, you have a link with STP1 and you have a link with STP2 as well. So your link set 1 will have a priority, will have a higher priority as compared to your link set 2. So all your communication is going to go via your link set 1, and if link set 1 fails, in that case, your communication is going to be done by link set 2. And next, you are creating M3UA links. So the command is the same. You specify your local IP addresses and its port, and you specify your peer IP addresses, and then you bind it to your link set index. That which link set index. So these two IPs belong to link set index 1, and these two IPs links belong to link set index 2. Okay. Then you have your SCCP OSP. So the SPN is going to be core only, the SGSN number you already know, and the originating point code of the SGSN. And this is for destination point codes. So its configuration is going to be the same as we studied earlier. Its operating point code, I mean, the operating point index is this, and the destination point code, since there are two STPs, so destination point code STP1 and STP2. Then we have SCCP SSN. For SGSN, the DPC OPC remains the same. Okay. For STP1 and STP2, it is going to be different. The OPC is going to be the same. The destination point code is going to be different based on your STP1. So this is for STP1, this is for STP2. DPC plus GT planning. Okay, so this is your IMSI. Now here, since we are using communication via STP, so here it is required to add the GT, the DPC plus GT communication, and here we are going to add the IMSI GT translation as well. The IMSI GT translation command is this one, okay, which we already checked. So this is the specific command, add IMSI GT and IMSI prefix. This is the IMSI prefix, and this is the GT, so 86139. So you have this number, and this is its IMSI prefix, the MNC and MCC, and this is the rest of the part. So you replace this with this command. What this command is going to do, if you send an attach request from your IMSI, this part is going to be replaced into this part. It's going to be replaced into this part, and then based on this part, you're going to identify that what is the from SCCP GT. You're going to identify that, okay, this is the GT, and what is the destination point code corresponding to this GT. So you will get the destination point code of the STP, and then based on your STP, the DPC of the STP, you're going to identify the which is the MP3P link of this STP via which I need to do the communication. Okay, so this is the SCCP. Sorry. Okay, so this is the SCCP GT configuration. Okay, and here you can see that this is the address, and this portion of the address, the 86139, is a portion that is going to be recognized. That okay, this is the, and that based on this GT, it is going to identify that okay, this is the destination point code. This is the HLR, which is going to be basically responsible for authentication and authorization of this specific IMSI. Okay. So you specify for HLR2, and then you specify for this is the DPC 0032, and this is the STP2. It has a different destination point code. Okay, and then again, the SCCP GT translation. This is for IMSI translation, and this is for the communication that is originated via HLR. So its NP type is going to be ISDN P. And in case of your SGSN initiated request towards your HLR, your numbering plan is going to be ISDN MS. And based on this, the destination point code is identified in your STP is identified. Okay. So this part gets replaced by this part, and based on this, you identify the DPC of the STP, and based on the DPC of the STP, you identify which NPO link is being used for communication with HLR. Okay, the third is if you have multiple HLRs. Okay, so you have an SGSN and you have a GTP and you have multiple STPs, and then they are communicating with multiple HLR. So that is based on your DPC plus GT, and its configuration is similar to what we studied earlier, that you have multiple. I mean, in case of one HLR, you're going to have two HLR. So STP1 HLR1, STP2 HLR1, and then STP1 HLR2, then STP2 HLR2. So it's communication. So you will have additional commands added here as well. Okay, and now we're going to look into if your USN is trying to communicate with a different, with an HLR that is in a different PLM, which is the roaming case. Is I think we can take a break of 10 minutes, okay, and then we will continue this. Okay, so let's have a break of 10 minutes, and then we can continue this. Okay, everyone, let's start. The 10 minutes break is over. So we were looking into the third configuration, which was with respect to your SDSN that is communicating with an HLR in a PLMN, which is your roaming case. For example, it's an inbound roaming case. A user of other PLMN comes to your network, so he's going to use your SDSN, but it's going to communicate with your home HLR in your home network. So how does it work? Okay, so your SDSN, your roaming, like your SDSN will be communicating with your STP, and then your STP via your gateway MSC is going to be communicating with the roamer's home STP, and then home STP will then communicate with your home HLR if it's PMM1 or 2, anything. Okay, so for this, the data planning that is required, your originating point code you already have. The local entity index you already have. The SGSN number. The peer entry index is just going to be the GT of your STP GT, and then STP will have all the routing information available where to route this specific GT to. Okay, then you have your signaling point code of STP1 and STP2. Then you have your own MNC and MCC. Then you have your own NC and NDC, the matched IMSI, and the matched IMSI part is basically that, okay, the MNC and MCC needs to be replaced with the CC and NDC, and addressing mode is going to be based on DPC and GT. So these are the three commands that are used: add connect PLMN, then add IMSI GT, and then add SCCP GT. The first one is add connect PLMN. Add connect PLMN, you specify the MNC and the MCC and the MNC. This is the MCC and the MNC of your roaming partner. Whichever operator you have a roaming agreement with, they will provide you that, oh, this is our MNC, this is our MNC, our MCC, and this is our country code. So in your connect PLMN, you're going to translate that MNC and MNC into the country code. And then in the MZGT, you are going to translate their MZ prefix into their global title as well. Okay. So the MZ prefix, the 46007 will be translated into 86139. And based on that, your request is going to go to your specific STP. Your STP is then going to recognize that, okay, this GT does not belong to me. However, so I will send this request to my, I have a gateway MSC here. So your gateway MSC will then have the information that, okay, this GT belongs to this roaming partner. So it will then route it towards the STP or the gateway MSC of that specific operator, and then specific operator will then translate it into your STP, and then your STP is going to communicate with your HLR for authentication. Multiple PLMN, how How do you mean by multiple PLMN? You mean to ask that if we have roaming agreement with multiple operators? Yes. If we have roaming agreement with 100 operators, then we'll have to have this configuration for multiple operators as well. We're going to have a separate session for how to do the configuration with respect to roaming, and I will cover that in detail. That if you have a request to do the configuration of another operator in order to ensure that his user is successfully live, so what configuration needs to be done? You need to do some configuration on SGSN. You need to do some configurations on your border gateway as well. So we will cover that in that case. This is just a case where I'm specifying that okay, how the MGGT is going to translate into the is going to be translated from your MG prefix into your GT, and then your how your HLR is going to be identified, and then HLR or your STP is going to identified, and that STP is then going to identify the home HLR. Okay, so here uh, the difference from previous configuration is that the address is just this MNC and MCT. Sorry, CC and NDC. Okay, so this is the CC and NDC is being translated into this destination point code of STP1, and then for STP2, again it's translated into this destination point code of STP2, and then for HLR number, this whole address is translated into your destination point code. The main functionality is that you need to, from your SGSN, you need to successfully reach to your STP. Once you have successfully reached your STP, then your STP has the functionality of identifying that which operator is this and how to route the request to that specific operator. Okay, once your commissioning is done, some of the commands to check the links. One is the ping command. If you're using the ping command, the source IP is going to be the IP that is configured in your service IP, and your destination IP is going to be the destination IP of your specific HLR or HTTP, whatever is configured. These are a few of the commands to check. Display M3 link is to check the M3 UA link. You're checking the route, checking your destination entity, whether your entity is up or not, your link is up, and your route is accessible or not. And then checking the DSP status, SCCP DSP status, checking your SCP, SCCP SSN, and the test SCCP GT to check whether the successful GT translation is being done or not. Right. So next we move on to the GB interface. We will quickly go through this because this is something that we've already covered lots of time. GB is the interface between SGSN and PCU. PCU is a component in your BSC that is used for communication of data. With SGSN, you have your control plane and you have your user plane available there as well. This is the protocol stack. You have your L1, you have your DSSGP, LLC, and GSM and GMM, and mobility management, and session management. And then this is for signaling plane. This is for your user plane. Signaling plane is your GPRS mobility management, session management, and in user plane you have the communication via GTPU. Is the protocol that is used. Okay, and on the BSS layer, I mean, this is the layer where your communication, like if you're adding a BSC, it is the network service layer on which the communication and coordination is done. Okay, so in BSC, in GB configuration, there are two types of configuration models. One is your static configuration and one is your dynamic configuration. As you can understand from the wording, in static configuration, you need to manually configure the NSC, the BSC. You have to manually configure the local endpoint and manually configure the peer endpoint. Local endpoint means specifying the IP address of your SGSN that is going to use communication with the BSC. And peer endpoint is a configuration of your IPN port of your BSC. In dynamic configuration, your NSC is automatically configured based on load sharing. Your local endpoint is also automatically configured, and your peer endpoint is also automatically configured. Okay, and this is corresponding to your communication in VM. Your IPU VM is going to communicate at layer 1 at physical layer and L2 layer, and SP is responsible for the rest of the layers communication. Okay, so when you have the data, what is required? Your IP address of the router router means the first node that your SGSN is physically connected to. In all of these three modes, it is required. Then IP address of the GB service IP, all of this required. Service IP needs to be configured. The local endpoint about the GB interface is required in your static configuration, but in your dynamic configuration, it is not required. And then your IP address and UDP port of your peer, it is required in static configuration, but is not required in dynamic configuration. And your NSCI is required in your static configuration and is not required in your dynamic configuration. This is an example. This is the IPU and the ports of your SPU, then IPU, and then IP and IP of your IPU. Then this is the IP of your router, and you have two PCU. So PCU one has one set of IPN port and another set of IPN port. This is usually we have a mesh connectivity. On SGSN side, we have a pair of IPN ports, and on the BSC end as well, we have a pair of IPN ports, so that if one IP is down, we still have a communication established with the other IP. So in case of two BSCs, we're going to have two sets of IPs and ports. Data planning, this you can check afterwards, is just the basic information that will be provided by your planning team based on which you're going to do the configuration. Okay. The first part, adding this service IP, this is going to be configured both for your static configuration and dynamic configuration, and this basically specifies the local IP address of your SGSN. So you have 4 IP addresses of your SGSN, so you're going to specify it in this service IP, and then these IPs will further be used later on if you need to check the link status. If you need to ping a BSC, you will be using these source IP addresses for that. Okay, so when we look into the static configuration, in static configuration, you need to add the specific NSC. So the command is add NSC. You will specify the name of the NSC or the BSC name. Then SGSN index. This index is going to be specified for this whole configuration. You need to specify the NSC ID. You need to specify the BSS ID. Okay. The next command is going to be configuring the local endpoint. So local endpoint is the local SGSN IP and its accordingly port. So your local endpoint for this BSC, your source IP address is this and your port is this, and so on and so forth. For the rest of the IPs, the configuration is going to be the same. So this IP and this port is going to be provided by the planning team to you, and then you will do the according configuration for each of these NSCs. And then you need to configure the remote endpoint. Remote endpoint means the IP. You need to configure the IPs of the BSCs. So the command is GB IP remote endpoint. You configure the IP address of the BSC and its port and the NSC, and then the other IP of the BSC and its port and the NSC. And then the same configuration goes for this second BSC as well. So as many BSCs you have, each BSC will have 2 commands because each BSC will have 2 IP addresses and 2 corresponding ports. Okay, so these 3 are the commands for static configuration. Okay, I will show you one of the commands that is we use in your live configuration as well. Okay, let me just share the screen with you as well. I hope the screen is visible. Okay, so this is the command that is shared for configuring one BSC on one SGSN. Okay, so you add an NSC. This is the name of the BSC, and then you have the SGSN index remains the same. These are 2 different BSS IDs. Okay, so usually what we do is that we configure the NSC ID and the BSS ID to be the same. The rest of the command is pre-configured points, which usually we do not change. The first is configuring the remote endpoint. So this IP with this NSC ID, and then the same IP with a different BSC ID. And then again, the first, this second BSC IP address with this specific port and the same IP address with a different port. And then we have the local endpoint IP configuration. Here, once again, we have a full mesh connectivity. So the first IP with first port, the first IP with second port, second IP with first port, and second IP with second port. Okay, so this is how the configuration for your the static configuration of BSC is done. Right. The next is how to do dynamic configuration. In dynamic configuration, you add all the your local IP addresses in the GBEP pool. Okay, and then you open all of the ports that can be used by the remote BSCs. Okay, so here using this command, GB local port with the begin port is 1024, the port end is 100. Okay, so you're opening all the ports because you're not configuring any of these ports and IPs, you're opening all the ports so that any connection that is initiated from the BSSN, all these ports are available to be used. Next is your BSS GP rule, like whatever NSC ID is provided, the same BSS ID is going to be assigned. For example, the NSC ID provided by the BSC is 201, the same BSS ID is going to be configured for that NSC as well. The next is your NSC attribute template, the GB. So it will, so based on this, you have different parameter indexes. If your BSC has a single IP address, then your endpoint number is going to be 1. If your BSC has 2 IP addresses, in that case, you'll have to have another configuration of NSC attribute. Its parameter in its era index is going to be different, and then you're going to specify that endpoint number is true. So if you are if a BSC is communicating with you that has 1 IP address, it will be communicating via this NSC attribute, and if it has 2 IP addresses, then it will be doing via this parameter attribute. Right. Add the binding relationship between NSC to the attributing template. Now, all you need to do is you need to specify that how many BSCs are you allowing, which NSC IDs you are allowing. For example, in your network, you have configured NSC IDs from, let's modify this a little bit. Let's see that we can do this as this. Okay. So you are allowing all the BSCs that start from NSC 2740 to 8700, and these are going to be bound with group index 1, which means that all these BSCs are going to be bound to this. All the BSCs are going to be bringing in just 1 IP addresses. And in case there are BSCs that bring in 2 IP addresses, then they are going to be bound to your group index 2, where we have specified that it will be bringing 2 IP addresses. And lastly, if you need to differentiate the NSC ID and the BSS IDs, in that case, the BSS ID for NSC ID, you can specify that, okay, for this NSC ID, you need to specify this BSS ID as well. Okay. So this is all configurable. But in comparison to your static configuration, you can see that we did not specify any local endpoint. We did not specify any remote endpoint. We did not specify any specific NSC ID here. All of these will be automatically configured. Right. So once your configuration is done, these are few of the commands to check your configuration is correct. Display service IP will give you the IP addresses that are configured for your local on your local side. Ping command is going to check the route status. So you're going to do ping. You will use the remote IP address, the source IP address, and the BSC IP address as the destination IP address. Then display NSC to check the status of the NSC, and display IP NSVC is used to check the status of your IP BSC as well. If you are if you need to verify it via tracing, you can enable a trace with that specific BSS, and the message that you should be looking is NS alive acknowledgement. Okay, so SGSN is continuously sending the NS alive messages, and if your BSC or PCU acknowledges that, that means your connectivity is up. In case your connectivity is not up, your SGSN does not respond to the NSLI message from your PCU. Okay, so you are not going to get a response from the PCU. Right, these are few of the commands. You can list cell of your NSE ID, so you can output the number of cells in this vertices. You can also enable a trace, a BSL GP trace, and that will then give you a specific cell that is contained in that PSCL PSC as well. So it can be either via this command or you can get it from trace as well. And then in order to check the paging table, the GB paging table, so you can run the command list GB paging, and it will give you the routing area index against each of the BSCs that we have configured. Querying the context, the GBMS context number can be used to count, to check the number of contexts that are contained or the number of users that are attached against a specific PSC. Right. So GB configuration, one is your static configuration and the other one was your dynamic configuration. Now we move on to the configuration of your IU interface. Okay, the basic concept IU interface is your communication between SGSN and RNC. The GTP-U protocol is used in your user plane, and your control plane uses SS7. A little bit of overview of your IU interface protocol stack. The NAP protocol, as we know, is used to process the signaling messages between SGSN and UTRAN, and GTP-U is used to transmit the user data that is used for user communication. Attack configuration, its data configuration is similar to what we studied in HLR, the GR interface, the same sets of command, SCTP parameters, service IP for local IP addresses, the local entity, destination entity, link set, route, and link. And then you have the similar SCCP layer information as well. Specifically, this part is different. Instead of the IMSI GT rule and your SCCP GT rule, you have your add RNC or add IU paging information as well. Right. So I'm just going to skip this part. This we already studied how to configure the SCTP para, how to configure this service IP rule. As I mentioned, that this is the source IP address SGSN that will communicate with the RNCs. Then your local entity and your destination entity. Okay. Here, since it is direct communication, so it's going to entity type is going to be IPSP. And your local entity index and your operating point code, as I mentioned, is unique from one SGSN, irrespective of whether it is being used for IU communication, GR, or any other interface. Then you configure your destination entity, and in destination entity, again, your entity type is going to be IPSP. And it's adjacent communication, so it's going to be true. And here you mention for which RNC this destination entity is being added. Next is your link set. Your link set index in a destination index. This link set index identifies this link set, and usually we keep the destination entity index and the link set index as the same in order to identify easily which RNC we are configuring. Then M3 route for this specific RNC. Next is the M3 UA link. Here each link is uniquely identified via its link ID. So here M3 link number 67. The local IP address 12 is going to be the IP addresses of the SGSN, and the peer IP addresses is going to be the IP address of your specific RNC along with its peer port. Then your CS is going to be, since it is IPSP, so it's going to be server. Link set index 120 is something which is going to bind this M3 link to this link set, which already we checked. Then ASF, ACT, and all that, and then you can mention the RNC name. The SCCP OPC unique for each SGSN. The destination point code is unique for each RNC. And the subsystem number, like for A NAP protocol, again, one subscription number entry for a NAP and one entry for SCMP. Okay, so if you are configuring two different RNCs, so we're going to have two different commands for that. Okay. Okay. Next is the command for adding. Once your SCCP information is done, once your M3 UA configuration is done, next is to add the RNCs. So the command to adding RNC is this: add RNC. RNC index is unique for each RNC. You specify what is the MCC, the mobile country code of the RNC, then you specify what is the mobile network code of the RNC, and then you specify the RNC ID. So each RNC is identified by its RNC ID, and RNC index identify this entry, and RNC ID is the ID of the RNC that is configured in the network. This signaling point code is basically the destination point code of the RNC. So it's based on this DPC that this RNC is going to communicate with this M3 link set and the M3 link and all that. So it's linked via this SPC. Right. So once you have the RNC added, you need to add different routing area IDs into it. If you remember, the smallest part of an area that SGSN can recognize is a routing area ID. So each RNC, under the coverage of each RNC, there are multiple routing area IDs. And if you remember the concept of intra-SGSN routing area, inter-SGSN, that was based on routing area ID. That if this routing area does not come under the coverage of one SGSN, then it is considered as an inter-SGSN, and then based on its routing area ID, it is going to identify its old SGSN and take its context. So under the coverage of one RNC, how do we define a routing area ID? It's via this command, add IU paging. You specify a location area ID, and then you add a rack ID to it. So its routing area ID is going to be 460001234001, and this is against the RNC index one. So this routing area is being served under the coverage of this RNC. In GB paging, in case of GB, the GB paging table is populated automatically, and it is sent, its GB paging information is automatically sent via your BSC site. So this needs, so we do not need to add any GB paging command over there. That is controlled from BSSN. But for 3G, add IU paging needs to be done for each of the routing area IDs. And this is a GTPU rule. This is just configured once, and for IUPS, and here you are specifying that which IP, and you are using your user plane communication. So which IP of SGSN is going to be used in case you're using non-DT communication. So here this IP address of GTPU is going to be used. Right. Once your configuration is done, you can check the destination entity via this command. You can check the route, you can check the link as well, you can check the DPC, you can check the SSN number, and each and everything is going should be connected or in the available state. In case it is not in the available state, then accordingly the troubleshooting needs to be done by checking the configuration that is provided to you and how you have configured that. Right. So I think these three we can do this week, and then we will move towards GNGP and GA next week, because 2 hours, approximately 2 hours have already passed. So I think this is enough for this week. Okay, Tilal, SGSN in pool, how we can configure. This was something that I was planning to discuss, but then the most of the colleagues wanted to do APN configuration and this and that. So SGSN pool we have not configured. We have not discussed this feature. Once this configuration part is done, then we will revert back to different features. And in those features, we are going to cover DT. We are going to cover SGSN pooling, MME pooling, and all that. So once we cover those features, we are going to discuss how the configuration of SGSN pooling is done. Because before restarting the training, I got a survey done, and one of my colleagues gave me the feedback And according to that, most of the teams, most of the students wanted to learn the configuration, specifically how APN is configured, how your SGSN configuration is done. So I routed the training towards this part. So once this part is over, we will cover the SGSN configuration, the MME configuration. Then we will go back. So we have a little bit of understanding. Then we'll go to how to DPI is configured. And once those basic configuration, OCS configuration, PCRF. So once that part is done, then we will revert back to the different features and how the configuration of those features is done. Okay, so any questions you guys can ask here, or you can send me a message one to one, and I will look into it. Any confusion or anything like that. These slides I'm going to share with you, most probably, if not today, by tomorrow, hopefully, I'm going to share with you the slides. The videos will also be uploaded soon. I'm just trying to find time to upload them and edit them a little bit, and then I'll upload the videos of last week and this week's lecture as well. Okay, fine. So thank you, everyone. Thank you for joining, and see you all next week, where we will be continuing the SGSN configuration, and if we have time, then we will start the MME configuration as well. Okay. So till then, have a nice weekend and take care, everyone. Allah Hafiz.